Hey everyone, this is Dr. Walker here. We're going to go over video 213. It is called Change in Potential Energy. So the first thing that we need to look at is a positive charge moving in an electric field. So in this picture we have a positively charged plate and a negatively charged plate. And this configuration produces a uniform electric field pointing to the right, away from the positive charge and toward the negative charge. So now we're bringing in this positive charge in here. What's going to happen to it? Well, we know that a positive charge always experiences a force in the same direction as the electric field. So the positive charge will naturally move to the right, under the influence of the electric field. So let's look at what happens when it moves, let's say, from position A, which we'll call it this line, and position B, this line. It moves from here all the way up to here. What happens to this charge? The electric field is doing work on this charge because there's a force to the right and it's moving a certain distance, right? So there's work being done. The work is F times the displacement, and then the force is Q times E. And this comes from the definition of the electric force, which was force per charge. So if you solve for force, you can see you just multiply the E times the Q. Okay, so the electric field is doing work on a charge when the charge is moving under the influence of this electric field. Let's take it a step further. When this happens, then the potential energy of the charge is going to change. So the first thing here is that I have written is the change in potential energy is the negative work done by the electric field. So this is something that we touched upon in Physics 1, that the work done by a conservative force equals a negative change in potential energy. For example, the work done by gravity was a conservative force, right? When gravity acts on a book and pulls it down, that work done by gravity reduces the potential energy of the book. So the electric force is also a conservative force, and thus the work done by the conservative force is a negative change in potential energy. So in this equation here, I'm just solving for the change in potential energy. So it equals a negative work, and we just saw in the previous slide that the work was QE delta X, so now we just have a negative in front of it. So what happens as your charge moves from point A to point B here is that its energy is going to change. Now, according to the discussion from the previous section, do you think that the potential energy is going to increase or decrease? So pause the video and think about it. Well, according to the note here, a charge naturally goes in a direction such that it decreases its potential energy. So as a charge moves from left to right, its potential energy will decrease. And we can actually use this equation to figure it out. And we'll do that soon. But first, I want to ask a question. Let's look at this your turn here. A positive test charge in an electric field pointing downward will move from A to B and blank electric potential energy. So this is a quick review question. Pause the video and think about it. So if your positive charge is moving downward, that is in the direction that it naturally wants to go. So its potential energy will decrease and it will lose that electric potential energy. So let's go ahead and summarize all of this and use that equation to see how it can be helpful. So I drew a couple different configurations here. If we have the positive charge plate on the left and the negatively charged plate on the right, then if the positive charge moves to the left or the negative charge moves to the right, they experience a gain in electric potential energy. And if the positive charge moves to the right and the negative charge to the left, then they experience a loss in electric potential energy. So let's do a couple examples to see how this equation can help us figure this out. Now, before even using the equation, you could just think about, is it going the way that it naturally wants to go? So in this case here on the right, it's going in the natural direction. We can say, again, this is just my term for it, natural direction due to the electric field. So we know that the electric field points to the right, and a positive charge always moves in the direction of the field, and a negative charge always moves in the direction opposite the field. So the natural direction, there's a loss, and there's got to be some kind of external force here in the picture on the left in order for the charges to move the opposite way. And that's when you're doing external work on these charges and increasing the potential energy. So you can definitely answer this conceptually, but now let's look at how the equations can help us. The equation is the change in potential energy. It's electric potential energy, but since that's the only type of energy that we're talking about here, I usually won't put the subscript, equals negative Q E delta X. So let's do it for the first case here. The electric field points to the right. Let's call anything to the right being positive and anything to the left being negative. So without numbers, we can just look at the signs. So we have a negative in front of the equation. The charge, is it positive or negative? Well, it's a positive charge. The electric field is going to the right, so that's positive. And then which way is it going? It's moving to the left, which is negative. So you can see by multiplying a negative number times a positive number, no matter what these values are, negative number, positive number, negative number, when you multiply all of those numbers out, you're going to get a positive number. So that tells you that the change in potential energy is positive, which means that you have gained potential energy. Let's do the same thing for the one on the right, and I'll leave you to do the two on the bottom by yourself. And if you have any questions about them, definitely post in the comments below. So we have the change in potential energy equals negative QE delta X. The charge is positive. The electric field is to the right, is positive. And the displacement is also positive to the right. So you can see that when you multiply all of these numbers together, you will get a negative number. So I hope this was helpful. Now that we've talked about electric potential energy, we will very soon be able to talk about electric potential. I hope you're ready for it.